Hello everyone, my name is Brian Keith and I'm going to present the work that I did with Dr. Mitra on narrative maps. In this work, we propose a computational representation for narratives. A representation is based on a roadmap metaphor, seen on the left side. So just like in real life we use roadmaps to get directions from one place to another, we would like to do the same with narratives. Find the routes connecting two events, like we see here on the right. This could be used by intelligence analysts, journalists, or fact-checkers to understand how events relate to each other. Now, the motivation of our work. Online news narratives play a very important role as basic block in societal sense-making. We would like to understand how they relate to each other to form narratives. And there exist similar works that extract timelines, story trees, or other similar approaches to represent stories. However, they have mostly neglected the theoretical foundations of formal narrative theory. So, in this work, we bridge this gap by creating a computational representation grounded in formal narrative theory. Our research questions are: how can we computationally represent a narrative? How can we extract a narrative representation from data? And how well does our approach work to represent narratives? To show you how we answered the first one, I'll use our case study as an example. Here's a part of our results with the coronavirus news narrative from January 2020. Narratives are a system of stories and events, and we represent them as directed graphs. Our representation has event nodes, which in our case contain the headlines of news. We also have discourse elements as node attributes. These are elements from narrative theory that give additional context to the events. In this case, we consider the source of the news event as an attribute. We also have the starting event node and the corresponding ending event node, which is not shown in this slide. We also have stories. In particular, the edge highlighted in yellow represents a story focused on China. We also have the concept of coherence from narrative theory, which refers to how much sense a storyline makes. We represent this with edge weights and visualize it using the width of the edges. We also have constituent events, which are the core events of the narrative. They are captured by the main road in blue. The main road is composed of constituent events, as we see here. We also have representative landmarks highlighted in green. The left one is a representative for a side storyline, and we call those supplementary events. And the right one is a representative event for the main story. So those are all our elements. And here we can see the full representation that we extracted from narratives, from the coronavirus narratives. So how did we evaluate this? So after creating the representation, we ran a user evaluation with two more maps. We evaluated how well does the map represent the narrative, how well does the roadmap metaphor work for narratives, and how well does the visualization itself work. And we did this using Amazon Mechanical Turk with 20 users per map. So overall, we got good results in all dimensions. But in particular, we found a trade-off between the size of the map and its completeness. Our maps balance this trade-off adequately. We also found that the effectiveness of the map seems influenced by its layout and by the previous knowledge of the user. Now the question is, how did we extract this? So here's the extraction algorithm. It consists of multiple phases. First, we extract and preprocess the data. Then we compute the coherence values using text similarity and clustering. Then comes the most computationally expensive step, which involves solving a linear program. Using the last result, we extract the main road and the representative landmarks. Finally, we generate the visualization with all these elements. There is some heavy machinery behind these systems, with elements from deep learning, clustering, graph theory, and linear optimization. In summary, our main contributions are a computational representation for narratives, an extraction algorithm, and the user evaluation. Our future work will focus on improving the algorithm, evaluating the maps with experts, applying these maps with fake news and misinformation narratives, and creating an interactive tool to explore these maps. Thank you for your time.